We're going to talk about factoring special cases today. And there are some formulas for doing this that you are welcome to use. And if you are interested in the formula method, you want to check out Miss Burkhead's video where she goes through how to use the formulas. I don't like to use a formula because that makes me feel like there's a new formula that I have to memorize. And, I already have a lot of formulas that I feel like I have to memorize. And you can work these problems the same way we've been working all the others. So to me, it feels natural to work it just like we've worked the others throughout this week. So if I'm factoring out here, I have a binomial, which makes it look different than it has looked so far. And there's no GCF for it, so it's not like that first just factoring out a GCF. So that would be my first thought. My second thought is that I have an x squared and a constant. And so I'm going to think about this as if it were a trinomial. And if I want to write it as a trinomial, the middle term, because I don't have that x term, it's like saying I have 0 x's. So I like to just rewrite it as though it's a trinomial. And then the factoring works the same as it has the rest of the time. So I have an a value of 4, a b value of 0, and a c value of negative 25. So my product of a times c is going to be 4 times negative 25. So my product is negative 100. My sum is a 0. I want factors that add to negative 100, or that multiply to negative 100 and add to 0. So pretty much, if you're thinking about this, factors of negative 100 that are going to add to 10 means that your factors have to be equal in number but different in sign, which would be like a negative 10 and a positive 10. These multiply to negative 100 and they add to 0. So if you could still use the Wolfram alpha thing if you want to. So negative 100 is our product, and then 0 is what we want the sum to be. And you'll see negative 10 and 10. So my middle term needs to be broken down to negative 10x and a positive 10x. So I'm looking at this 4x squared, and I'm strategically thinking where I want to place stuff. 4x squared. I have a negative 25 here, so I think I'm going to put the negative 10 with the negative 25, and I'm going to put the positive 10 with this positive 4x squared. Next, you have your first two pieces, your second two pieces, and we're going to factor out our GCFs. The GCF for 4 and 10 is a 2, and x squared and x is a x. So we're going to factor out a 2x. 4x squared divided by a 2x is going to leave 2x. It's 2 times 2 is 4, x times x squared. 10x divided by 2x is a positive 5. Next pieces here, we've got negative and negative, so we're going to take out a negative because the first one is a negative, is always a sign of whatever that first piece is. They're both divisible by 5, so I'm going to take a 5 out. Negative 10x divided by a negative 5 is going to be a positive 2x. Negative 25 divided by negative 5 is a positive 5. Notice that this binomial is the same, therefore you did that part correctly. And so we have 2x minus 5 from our GCFs and 2x plus 5 for those binomials next to it, and that is the factored form. What makes it special is that they are matching except for that middle sign. And since they are identical except for that middle sign, that's why that middle term equals to 0. Here is another one following that same kind of pattern. X squared plus 0x minus 36. A is 1, B is 0, C is negative 36. A times C, 1 times negative 36 is negative 36. B is 0. So we want to have a product of negative 36 and a sum of 0. So negative 36, sum of 0, negative 6 and positive 6. So negative 6x and a positive 6x. And so I'm going to rewrite this trinomial, x squared. I'm going to put the positive 6x with that one, and the negative 6x next to the negative 36. Two terms, two terms. First two terms, we can factor out an x, which will leave x plus 6. Second two terms, we're going to factor out a negative 6, which will leave x plus 6. Then our answer is x minus 6 times x plus 6 for the factors. Again, they're matching except for the sign. So this is called the difference of squares when you have a minus sign, and these are both perfect square pieces. And so you end up with the square root of each part. So the square root of x squared is x, and the square root of 36 is 6. And then you have matching factors with those square roots, and one with a plus sign and one with a minus sign. That's the difference of squares. Here is not the difference of squares, but it is also a special case. And so I'm going to factor it, and then I'll talk about why it's special afterwards. We do have 3 parts, so it looks just like all the problems we've been factoring earlier in the week. A is 1, B is negative 8, C is 16. So I want to do A times C, 1 times 16, 16. B is negative 8, so we want to have a product of 16 and a sum of negative 8. Product of 16, sum negative 8. Negative 4 and negative 4. So negative 4x is what our middle term is going to break up to. So we have x squared minus 4x plus 16. Notice how these are identical. That's what makes this one a special case. Next, we're going to be factoring out our GCFs. The first two pieces have a GCF of x, leaving behind x minus 4. The second two pieces have a GCF of negative 4. It's always whatever the sign is of this one. And that's going to leave us with 1x, and or just x. You don't have to write the 1. And then 16 divided by negative 4 is negative 4. Again, our binomials match, so we feel good. X minus 4 are the GCFs, and then the binomial next to it was also x minus 4. Again, this is a special case, and they match exactly. So when they match exactly like this, you're able to write it as one of those binomials to the power of 2, because you have that binomial times itself. And that's what makes this a special case, is that we can rewrite it in a simplified form like that. This one's a little bit different than the previous one, just because this one had a negative sign and a plus sign. This one has a plus sign and a plus sign. So not exactly the same, but kind of flows the same way. A is 1, B is 6, C is 9. A times C, which is 1 times 9, is 9. B is 6. So again, we want this to be the product and this to be the sum. So product of 9, sum of 6. Product of 9, sum of 6. 3 and 3. So we got 3x and 3x from that. So we're going to have x squared plus 3x plus 3x. Again, those match. That's why it's called a special case. First two, second two, factor out your GCF. First two have a GCF of x, leaving behind x plus 3. GCF of the second two is a plus 3, leaving behind x plus 3. Your GCFs will give you the first binomial, x plus 3, and then what was next to them gives you that second binomial, x plus 3. Since they are identical, you can merge them to write one binomial to the power of 2, x plus 3 parenthesis squared. Here's our last one. And it just, compared to the last one, the a was 1, here the a is 4, and so just wanted to do one where a was 1 and a was more than 1. So the a is 4, the b is 12, the c is 9. A times c, 4 times 9, 36, b is 12, so you want your product and your sum. Product of 36 and sum of 12. Six and 6. So your middle term is going to be split up to a 6x and a 6x. And copying the first term and the last term. And then you have your 2 parts and your 2 parts, and you're going to factor out your GCF. Factors of a 4 and a 6, the GCF is 2, and then x squared and x is an x. Taking out 2x, 4 divided by 2 is 2, x squared divided by x leaves x. 6x divided by 2x will leave you with 3. Second binomial set, 6x and 9, GCF is going to be a 3. That's the most you can take out of a 6 and a 9. So taking out a 3, and it's positive because it was a positive 6 there in front of the x, is going to leave you with 2, if I could divide correctly. So 6x divided by 3 leaves you with 2x, and then 9 divided by 3 leaves you with 3. Those binomials match. We're in good shape. You write your GCFs, which is the 2 and the 3 here. 2x plus 3. And then your binomial that was next to it was another 2x plus 3. Again, this is a special case, and that's why it's a special case. It's kind of weird, and they're matching. And so you're able to write it as that one binomial squared. And that's factoring special cases.